2008, question 7, core 2. Let's have a quick read what it says. Diagram shows y equals a times bx, where a, b are positive constants. Curve passes through the points 0, 4, 1, 4/3, and 2, 4/9. Right, part 1. Use trapezium rule with two strips of each with 1 to find an approximate value for the area enclosed by the curve, the x-axis and the y-axis, with line x equals 2. Okay, so let's have a quick go. What I'm going to do is I'm going to quickly just sketch this here, and I've got this curve here going on there. So I'm going to have to do strips here with length 1. So if I start from 0, this is the y-axis, and it's going on here, which is the x, and then this length 1, and this will be 2. And it does here with two strips, so I'll go from there and there. So I've got that, and I've got that. Okay, two trapeziums here. I know that this point crosses here at 4. I know at 1 the length is going to be 4/3, and I know at 2 the length is going to be 4/9. Okay, so I've got this drawn on here. So I've quickly just sketched that. So this is the curve y equals a times b to the x. So I want to find trapezium rule, find the area of that, and that gives me all the area, as it said, with those two strips between the y-axis, x-axis, and the line x equals 2. Right, here we go. So first thing first, I'm going to put x. I'm going to go 0, 1, and 2. Corresponding y values for 0 is 4. Corresponding y value when x is 1, y is 4/3. And corresponding y value is going to be 4/9. Now it is trapezium rule, so what I need is one lot of that, one lot of that, and I'll get two lots of this. So that's going to give me 4. That's going to give me 2 times that will just give me 8/3, and 1 times that is going to be 4/9. Now if I went and add all these up, so I just get my calculator, I just simply put in me, switch it on. We just change this mode quickly and put it to degrees again, as I changed it earlier on. And then I'm just going to go 4, add 8/3, cursor that way, add 4/9, that's equals, and I've got 64/9. That's the total of these two. So if I put it through my trapezium rule, I'm going to get, so what do I get? I get the area is going to be half times the height, which is the width here, which is just 1. And it's the summation of all my ordinates here that I need is 64/9. So times that through, I'm going to get 64/9,918, which if you just times that, and just quickly, I've still got that, multiply that by 0.5, I'm going to get 32/9. And if I want it as a decimal, it's 3.5 recurring, or 5/6 if you want to put it. Okay, so that's the two spaces. So there we go. Now it says here, use the trapezium rule with two steps, two strips, each with 1. Find approximate value for the enclosed area of the curve. Right, so that will be 3.56 to 3 single figures. Now it goes here, find the values. Question 2 says, find the values of the positive constants a and b. So let's go back doing that now. So values of a and b. So if I say y equals a times b to the x. Now I've got some points here. I've got some points, but let's try the first one. 0, 4, x, and that's y. So when y is 4, that must equal x is 0, so a times b to the power of 0. Anything to the power of 0 is 1, so that implies that that goes to 1. 1 times a is a, so 4 must equal a. Very simple, straightforward. Got that one. And if I put my second point in, so again I've got another point, and it does tell me all those points on the strips here. I've got this one, 4/3. So I put that in. When x is 1, y is 4/3. So that means y is 4/3, which is equal to, now I know that a is 4 multiplied by b to the power, x is 1. So anything to the power 1 is just b itself, it's just itself. So that's going to be 4 times b. Take it to the 4 to the other side. So just times that by 1/4, times that by 1/4. So that gives me b, which will equal 1/4 of that, will just give me 1/3. So b is equal to 1/3. So we've got a equals 4 and b equals 1/3. So therefore your equation is y equals 4b, let's write that again. Y equals 4 brackets 1/3 to the power x. That's what we got in equation. We might need one of these in the third part of the question. We'll have a quick read what it's asking us for the third part. Right, let's see what it says. Now, let's just flip over. The curves y equals a times b to the x and y equals a to the power of 3x minus 1 intersect at point P. Use the values of a and b from part 2, which we suggested we might need to use, to show that the coordinates of P, x coordinates of P, can be written as follows. Right, okay, so we said earlier on that we know that y is equal to 4 to the power 1/3 of x. And we've got here, the second equation, what it's told us is y is equal to, now it does say use the values of a and b. So this a here is going to be 4. And that's going to be 3x to the minus 1. Okay. Right. So now I'm going to just simply equate those two. So when we find a point of intersection, we make the two values equal. So I'm going to make 4 to the power of 3x minus 1 equate it to 4 power 1/3 to the power x. 4 times 1/3 to the power x. Now there's 4 in common in both of them. So what I'm going to do is, if I divide that by 4, I'm going to divide the other side by 4. Okay, so I'm going to get 3x to the minus 1 divided by 4 equals, now 4 divided by 4 is 1, so that's just going to be 1/3 of x. Now just be careful here, dividing by 4 is just pointing that to taking another power off from here. Okay, so we literally, when the base is the same, okay, we know that's to the power 1, we can just do that power, take away 1. So what we end up with is 4 to the power 3x minus 2, because we're dividing by 4, so we're taking 1 more off there, and that will give me 1/3 to the power x. Okay, now once we've got it in this form, I'm just going to put brackets here too. We've got x's in the powers, so the best thing to do here is let's log both sides. If we log both sides, log to the 4, this enables us to bring the power down. 3x minus 2 equals log this side, which is log of 1/3, bring the power down, which is x. What I now do is simply I'll expand this out, so I get 3x log 4 minus 2 times that, 2 log 4 is equal to x log to the 3rd. I'm going to bring all my x's to one side, and anything that's not x, take it to the other side. So this goes on here by minusing, and this minus 2 log 4 goes to the other side by adding. So I end up with 3x log 4 subtract x log to the third, which will equal 2 log to the 4. Now, I've got x's in both of them, so I'm going to just simply factorize that. It's a common theme that they tend to do in most questions, so when they want to get the x, so we just take the common factor x out. So what we end up with is 3 log 4 minus log 1/3 equals 2 log to the 4. Now simply x is equal to 2 log 4 all divided by 3 log 4 minus log to 1/3. Now, we have been asked in the question that we want to make the quadrant look like x equals 4. There's a 6 there, and that's going to be log to 2. So it's asking me to put a base 2 in there. Okay, so what I'm going to do is I'm going to put everything to the base 2 here and see what happens. Okay, now there are some tricks here. Now what's going to happen here is I'm just going to put them out clearly. So I've got 2 log to the base 2. I'm going to put that 2 squared. So we can see what's going on, because it's base 2. If I can put that there, everything's going to drop out very simply. Same with this, you got 3 log there, the base 2, and that's going to be 2 squared. And here you just need to be a bit careful. I'm going to just split this up. I'm going to split this up because that's going to be a minus, so I'm going to just put big brackets here. Now log to the 1/3 is the same as log base 2 to the 1 minus log base 2 to the 3. Okay, let me just explain what I've done there. So you should have this understanding of logs. First of all, I'm just changing those 4s to 2 because I'm going to show you what a little trick I'm going to use in a second. And secondly, when you got log of 1/3, that log can be split up as log to the 1 minus log to the 3 because it's divided by, it's like the rule log A over B is log A minus log B. Okay, so I'll just simply use that. Right, so let's see how does this help us. First of all, if you're log to the 2 and this is to the 2, okay, you just simply know that that will equal to 1. So the rule here, if you got log A to the A, that is 1. Okay, we're using that simple rule. So if that is 1, what are we left with? We are left with 2 here. So what we're going to put that is, that's going to be 2. And what we left with here, as that goes to 1, we just left with 2 there. Okay. Next thing, same reasoning. If we're using this rule, put in that log to the base 2 of 2, you're just going to end up with that power, which is 2. So we're just going to get 3 open bracket with a 2 there, minus. Now, log to the 1, anything, I mean log of any base to the 1 is going to be 0. Okay, so that will be 0, and minus minus becomes a plus, and that will be log base 2 to the 3. And if we smarten this up, 2 times 2 is 4, 3 times 2 is 6, and with 6 take away 0, that doesn't matter, and then we add in log base 2 of 3, which is QED as required. That is the x coordinate of P, which you see from the question, that's what it wants us to show, is 4 log 6. So it's just using some rules of logs to show that. Okay.